I can describe the transformation that occurs between two linear functions. Here's what you need to know. We have our parent function, f of x equals x. Any other function that you see is some sort of transformation of that original parent function. We talked about these in a previous video, all of the possible changes or transformations that we can have on an equation or on a function. Remember that your vertical and horizontal translations just change your intercepts. Your vertical and horizontal stretches and compressions change your slope and your intercepts. We are going to be comparing two different functions and seeing what change is happening between them. So let's see which statement correctly describes the relationship between the graph of f of x and g of x. So I see that f of x is negative 2x and g of x is my f of x function, but I'm going to be subtracting 7 from the x value instead of leaving it alone. What you're really looking for is the changes that you see between the two. So look for the change that g of x makes to f of x. G of x is transforming f of x, turning it into this right here. It's saying, hey, we don't want f of x, we want f of x minus 7 instead. So everywhere that I see x in my original function, I'm going to be putting x minus 7 in its place. So don't really worry about what f of x says, it's just there to give you a starting point. You're looking for what g of x tells you to do to f of x. In this problem, it's telling me to use x minus 7 as my input. So x minus 7 represents a horizontal translation 7 units to the right. That's what the minus 7 inside the parentheses right here represents. That's a horizontal translation, 7 units to the right. So that means that C would be the correct choice for this one. So again, we ignored this f of x equals negative 2x. I don't care that it's negative 2x. It doesn't change what this question's asking me. It's asking me to describe what this right here where I'm pointing, what this transformation is. And so it's telling me to take my original function, whatever it is, we don't care that it's negative 2x, it could be anything, and we're going to be translating that 7 units to the right. We're going to be choosing the statement on this one that does not describe the relationship between the two. So pause and try this one. We're looking for the change that g of x makes to f of x. G of x is transforming our original f of x into this. It's saying take f of x and multiply it by negative 2. So that's what it tells us to do. Negative 2 up in the front represents a vertical stretch by a factor of 2, and because it's negative, that's also a reflection over the x-axis. So again, this question asks you to choose the statement that does not describe the relationship. So we're going to check these. A says that we have a horizontal compression. That's not true. The answer to this one is A, because that's the false statement. B and C are the translations that are happening on these functions. I can determine the equation of a linear transformation given the equation of the original function. So now we're going to be working backwards from what we just did. We use g of x as a rule for transforming f of x. You have your transformed function and your original function. Here are some examples. Take a look at the very first line right here. G of x, my transformed function, is equal to f of x plus 2. That means that I'm replacing x with x plus 2 everywhere in my original equation. In the second line, g of x equals 2 times f of x. My rule is to multiply my entire original function by 2. In the third line, g of x equals f of 2x. I'm going to replace plain old x with 2x everywhere in my original function. Remember that whatever value you have in the parentheses right here just represents your input. It's telling you what to plug into the equation. And then this last one right here, g of x equals f of x minus 2. You're going to be subtracting 2 from your entire original function. Let's do an example. Write the equation for g of x. So you have your original function f of x, and then a rule. So this is telling you what to do. G of x is telling you to do 4 times f of x and then add 1 more. Notice how we aren't changing our input. The value right here in the parentheses is still x. I'm not changing what I'm plugging into my function. I'm just doing things to my function. We're going to follow our order of operations. We're going to be multiplying by 4 and then add 1 because that's what the order of operations tells us to do. We do our multiplication right here before we can do our addition. So all I'm going to do is replace f of x by what f of x is. I know that my original function is 2x plus 1, so I'm going to slap that right here and do 4 times 2x plus 1. And then I'm going to be adding 1 more at the end of that because my rule, g of x, tells me to. Always combine like terms whenever you can. This is my brand new transformed function. You can pause and try this one. We know that f of x, our original function, is 3x plus 4, and then g of x, our function rule, tells me to take my original function, and I'm going to use x minus 2 as my input. Put x minus 2 in the place of x everywhere in your original function. So I'm going to do that here. I'm just plugging in x minus 2 in the place of x into my original function. Everything else stays the same. I'm going to use my order of operations to simplify this down. I distribute and then combine my like terms. So my transformed function g of x is equal to 3x minus 2. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.